So that is the idea of instantaneous rate of change. And so the last thing we want to do here in this short topic is link it to an idea in the business world called marginal change. So the marginal change for a function is the amount of change that occurs in the y direction if you allow the x direction to change by only 1 unit. So for example, if we talked about the marginal profit, it would be the total change in the profit, or the total amount of additional profit generated, either positive or negative, that comes from selling 1 additional unit, selling and producing 1 additional unit. So you're always measuring what's happening on the next item. You also maybe have heard of like your marginal tax rate that the federal government applies to your paycheck. So if you were to earn $1 more, then the government will charge you some specific tax rate, and that's called your marginal tax rate. So that's the idea. Marginal profit, marginal revenue, marginal cost, they all mean the same thing. If I, let's say, produce 1 more unit, then the marginal cost is how much more I have to pay for that 1 extra item. If we're talking about marginal revenue, if I sell 1 more unit, then the total additional revenue that is generated is called the marginal revenue. And keep in mind, marginal revenue and marginal profit can be either positive or negative. Marginal cost will always be positive. Think about why that's true. But marginal cost is always positive. Marginal revenue, marginal profit can either be positive or negative. If you're not sure why that's true, go back and look at some basic revenue and profit curves and compare them to cost curves that we've explored in this course. So here's the link between marginal change and all of the ideas we've sort of been talking about, both in this topic and in the previous one. If you recall, marginal change is the total amount of change in the y direction that results from a change of 1 in the horizontal direction. So really, it's just the average rate of change over 1 unit. And it is, in fact, just the slope of a secant line, or the line that cuts a graph in 2 points. The 2 points it's cutting are, first, the point that you care about, A, and the second point, which is 1 unit beyond that, which we called A plus 1. So we can also talk about an approach called the forward-only approach, which means you don't go forwards and backwards. You pick a point, let's say Q equals 20. You go forward to 21. You measure that change. That is the slope of a line between those 2 points. But because you're only changing by 1 unit, it by default then is the marginal change. So we'll call this the forward-only approach, but it's essentially equivalent to the marginal change. So let's take a look at a little bit more on that. So here's where we begin to make a transition from all of these relatively basic calculations involving slopes and slopes of lines to the more abstract ideas behind calculus. In a business calculus context, when we refer to marginal change, we typically take that to mean the slope of the tangent line. Now, you may need to go back and look at some of the graphs that we've been generating here, but remember, a tangent line just cuts the graph at 1 point. Marginal change, the way we've defined it formally, is the slope of a secant line. But if you think about it, if you only change by 1 unit, the slope of the line between those 2 points, the point you care about and then 1 forward, should generally be very close to the slope of the tangent line at the point that you actually care about. So because those 2 slopes are generally close to each other, we just say, all right, we're going to measure marginal change with a tangent line. And that is going to become incredibly important in the next topic, because that's how we're going to define what we mean by marginal change and marginal analysis. And we'll come up with a much more efficient and actually much more accurate way of doing that next topic, but let's explore a little bit before we get to topic 4. So we're back to our profit equation that we've seen several times now, and if we go back and look at a previous slide, we found the instantaneous rate of change using the forwards-backwards approach to be $125.50 per unit when 20 units have been sold and produced. So now we want to use the forward-only approach to compute the marginal change. So let's go ahead and do that calculation on the next slide, and then we'll compare it to what we got in the past. Okay, so in this example, final example, we're computing the marginal profit at 20 items. So first, notice this new notation that I'm using, MP, capital MP for marginal profit. This is notation that I've seen in econ textbooks and that we'll use throughout the rest of the quarter. So we're computing the marginal profit at 20 units, and we're doing so using the forward-only approach. So the way we do this is we go forward 20 plus 1 to 21 units, and we compare that to the original value of the profit at 20 units. So here we're going forward 1, and the second piece here, we're not moving. We're not going backwards. We're staying at the 20 that we started with. So this is forwards only, and this is how the computation would look. So if we do forward only, we're going to do P at 21 minus P at 20. And P at 21 is here in red. There are the calculations for you to look at. I'm just plugging 21 into the profit curve. Then I'm subtracting off the value of the profits at 20 items. That's done in blue. And then I just compare those two values, and I get a final result of 122.5. So let's wrap all this up here at the end with this example. Using the forwards only method, we found that the marginal profit at 20 items was $122.50 per item sold and produced. If we go back and we look at the forwards backwards method, we got $125.50 per item sold and produced. Now, if you go back and you look at the picture that we generated using forwards backwards, we got a secant line that was very close to being parallel to the actual tangent line. Now, what I want you to do on your notes, on your paper that you're taking notes with, is sketch a little graph of what the forward-only method would produce in terms of the lines. Would the line that you get by going forward only give you a line that is as close to being parallel as the forward backwards method? Sketch that graph, maybe sketch them together, and ask yourself this question: which one is a better approximation? And I'd actually encourage you here to pause the video and sketch that for yourself and see if you can answer that question. So basically compare the two approximating lines to what the actual tangent line slope should be and find out which one you think would be better. I'll give you a second here to pause that, and then you can come back. So hopefully you've actually done what I suggested, sketched a curve here of these two possible estimating methods on paper. And now I want to tell you what the actual result from calculus is. And it is actually the same as the forward-backwards method. Does that make sense? Turns out that generally speaking, the forwards-backwards method will be a better approximation. In this case, it happened to be exactly the same, which is a coincidence. It's not always going to happen. But generally speaking, the forwards-backwards method will give you a better approach because that symmetry of going forward and backward in both directions, one unit, allows that secant line to be more parallel to the tangent line that it otherwise would be. So that's the reason for that. So be careful here. I'm not saying that the actual value will always be the same as the forwards backwards. In this case it happened to be that, but the general idea is that forwards backwards gives you a better approximation. Now keep in mind, We have to balance that with what we just said about what we mean by marginal change. In this course, starting in topic 4, when we talk about marginal change, we're going to be talking about the slope of a tangent line. And so the marginal change, which is really just the forwards only method, is not as good an approximation, but given the ideas that we'll see in the next topic, we will take marginal change and slope of a tangent line to be synonymous with each other, the same. Right? So there's a little bit of loose ends to clean up there in topic 4, but for now we've finished the foundational material that we need here in topics 1 through 3, and now you have a good idea, hopefully, of what we mean by measuring rates of change. We're going to do it by computing slopes of lines, and the way we're going to do it in particular is by computing the slope of tangent lines. We will formally introduce the tools to do that in topic 4. We call those tools derivatives, and until then you'll practice some approximation methods. All right, moving forward.